Hi, my name is Mercedes, and I will be covering Chapter 23, Section 7, Halogenation at the alpha carbon, and Section 8, Direct Enolate Alkylation. Halogenation is a substitution reaction where a ketone or aldehyde is reacted with a halogen like chlorine, bromine, or iodine, and either a base or an acid will result in the substitution of a halogen for hydrogen at the alpha carbon, forming an alpha haloaldehyde or ketone. First, we're going to do a halogenation reaction at the alpha carbon with an acid. We need to first look at who wants electrons and who has them. The proton wants electrons and the oxygen has them. Water will then deprotonate the hydrogen at the alpha carbon, which pushes electrons here and pushes these ones off. This then forms an enol, which will then react with the chlorine because the electrons from the oxygen will come down here, pushing the electrons from the enol to the chlorine and removing one of the chlorines. The second chlorine will come in and deprotonate the ketone to remove the positive charge. This then is our product, which substituted the hydrogen for the chlorine at the alpha carbon. For a halogenation reaction with the base, the hydroxide would deprotonate the hydrogen to form an enolate, which pushes this pair of electrons here. Next, the enolate would react with the chlorine by the electrons coming back down here, and then electrons from the enolate coming and reacting with one of the chlorines, and another one leaving. However, since we still have a hydrogen at the alpha position, another base would come in and pull off this hydrogen, pushing the electrons back up here. This forms another enolate, where the electrons would come back down here, and then the electrons from the enolate would come and react with another chlorine, pushing the second chlorine off and forming this product with two chlorines. In a reaction of alpha halocarbonyl compounds, we have the bromination at the alpha carbon, which is accomplished with Br2 and H+. Next, we can eliminate the bromine at the alpha position and the hydrogen at the beta position by reacting it with lithium carbonate and lithium bromide in DMF. A new pi bond will then be formed, which results in an alpha-beta unsaturated carbonyl. In a direct enolate alkylation, we can react cyclohexanone with LDA and THF at negative 78 degrees Celsius to form enolate Next, we'll react the enolate with an alkyl halide, and we have to look at who wants electrons and who has them. The carbon with the halogen wants electrons, while the carbon at the alpha position has electrons. So this pair of electrons will come down here, pushing these ones off to this carbon, and then the carbon that has electrons will attach to the carbon who wants electrons, making the chlorine leave, forming our new product. Reactions done in acid generally involve enol intermediates, and reactions done in base generally involve enolate intermediates.